This conference will now be recorded.
All right, this is a video of the 6.4 values of trig functions. I wasn't able to get a pre-video recorded early enough, so what I'm going to do is I'm going to do half of the problems on this video and we'll do the other half in class. That way we will be able to successfully move through the section and hopefully start 6.5 as well in our next class session. So what we want to look at is the definition of a reference angle. So let theta be a non-quadrantal, that means not on the actual x or y axis, angle in a standard position. The reference angle for theta is an acute angle called theta sub r that is on the terminal side of theta that makes with the x-axis. In other words, wherever your angle actually ends, the reference angle is always from that side that it ends on to the x-axis. So it's always going to be this acute angle in one of these quadrants. If it's in quad 1, the angle is the reference angle, because remember, everything in this group is less than 90 degrees. If you're in quad 2, remember this measures something between 0 and 180. So to figure out this smaller part, you just do 180 minus theta, or if you're in radians, you do pi minus the theta, whatever that is. And then for quad 3, you've gone past 180. So it's actually your angle minus the 180. So you're taking away this whole top half. Or you could do the angle minus pi. And if you're in quad 4, it's 360 minus the angle, because remember this is the angle right here, or 2 pi minus the angle, and that'll tell you what's left over. So there's a theorem on reference angles that says if theta is a non-quadrantal angle in the standard position, then to find the value of the trig function at theta, find its value for the reference angle, theta sub r, and prefix the appropriate sign. So in other words, if you know what this reference angle is, you can pretty much reference everything back to quad 1 and just remember all science teachers are crazy to help you figure out the signs of all the trig values. So we're going to look at these first ones. This is just really simple. We're just trying to figure out the reference angle for each of the thetas that they've given us. So I'm going to draw a picture as we go. So for 310, notice that that is going to be in quad 4 because 270 is when you're right here. So this is 330 degrees. To figure out what's left over, then we would do 360 minus the 310. So this theta reference angle here is 360 minus 310, which would be 50 degrees. So that's the reference angle for this first one. For 260, that is less than 270, so we're going to actually be in quad 3 down here. So for quad 3, you're wanting to know this piece right here. So let me highlight it in red, because this was our reference angle right here. Here is our reference angle. Notice to get our actual red part, we need to take the angle minus all of this top part up here. So that's why it's going to be our angle 260 minus the 180. And that is going to be, because this is 180 to 270, that's 90 degrees. So we're just not using the 10 degrees and the 90 degrees, so that's going to be 80 degrees. You can do the subtraction. I was just doing kind of subtracting it backwards. Now, the ones that are usually harder are the 3 and 5 versions. So for 3 pi over 4, you have to remember where is that located on our unit circle. 4 pi over 4 is pi, so, and then remember pi over 4, 2 pi over 4 is pi over 2, so 3 pi over 4 is located right here. So that's the angle. To find the reference angle, we want the other piece that's kind of going down to the x-axis. So remember, all the way across is pi, so we're doing pi minus the 3 pi over 4, which if you make that a 4 pi over 4, so it has a common denominator, you'll notice that it is just a pi over 4 angle. So my theta reference angle. For 4 pi over 3, 3 pi over 3 is pi, so 4 pi over 3 is going to fall in this third quadrant right here. So remember, if we're in quad 3, we want the little piece that's kind of already overlapping right here. So this is our angle minus pi, because we're taking away the top half. So 4 pi over 3 minus, and I always go ahead and make it the same denominator. So if you subtract pi, it's 3 pi over 3, and so this is just pi over 3 for the reference angle. Okay? So we have our reference angle for the ones that have degrees and our reference angles for the ones that have the radians. Now this is also radians down here, but these are not the ones that have the pi. So it's hard to actually get these, and we don't want a decimal answer. So we're going to have to think about what they mean. So I always tell people you want to remember what the 4 quadrant ones are. So, and as a decimal, it kind of helps you place things. So Pi divided by 2 is the top measurement. So that's 1.57. So sometimes this just helps me place my number. 3.14 is pi. This was pi divided by 2, and then if we times it by 3, that's 3 pi over 2. So down here is 4.71. And if you remember, 2 pi was 6.28. So 3 is going to fall in quad 2. So this is a measurement of 3. So if you want to find your reference angle when you're in quad 2, remember you do pi minus this angle. So that is going to just be written as theta reference is pi minus 3. So it actually is pi minus 3. And that's all we're going to write. We're not going to go to decimal point for that. And then if we're doing -2, that's going to be a little different because we're going, remember, clockwise for negative angles. So notice that if you go -2, up here, if you notice, a 2 would put you in quad 2. So if we're going the opposite direction, it's going to put us in quad 3 because it would be the same measurement but the opposite direction. So this would be -2, essentially. And remember, when we're in this quadrant, it's going to be backwards for us because this is actually kind of like what we do up here. See how this is this piece with the extra piece hanging down. It's not the normal way that we do quad 3 because we're going in the opposite direction. So the way I like to think of this one is that it's just pi minus that angle. So it's actually pi minus the -2.
This conference will now be recorded.
Sorry, my internet went out for a second. So let me restart over on this last problem. So remember, we're going the opposite direction, so I actually missed one piece right here. This is -pi. So this is -pi because we're going in this direction minus this little -2 part that we have here. So it actually ends up being -pi plus 2. So that's that theta reference angle. Now, something I noticed in your homework on both of these is that they actually have you convert these to degrees for the reference angle. So this would be if you needed to convert this to degrees. So if you need degrees, because like I said, that's what the homework does, you need to take this answer. So we would take our calculator. We don't do that on a lot of the problems. We leave it as the pi minus 3, but I did look at the homework real quick and they do convert it to degrees for some crazy reason. But this would be pi minus 3, and then you would times that by the 180 divided by pi. So 180 and then divided by pi, and notice that is 8.11 or 8.1. So notice that's how small that angle would be because it's really close to this part. So this would be about 8.1 degrees as a reference angle. Now this one's a little different because it's going to give us a negative reference angle, but we would write that positively because we're just going in the opposite direction. Still the reference angle would be how much does this measure? So 2 minus pi and then times by 180 divided by pi to convert it to degrees. That gives us a -65.4. So in degrees, we would just say 65.4 degrees. Okay, so that's how, if you're doing the homework, you would convert those. Okay, so let's move on to the next topic. This is saying find the exact value. So we're looking at sines, cosines, tangents, and I think on the next page we'll have some reciprocal functions. So 2 pi over 3, if we want to know what the sine of 2 pi over 3 is, if you don't have your unit circle memorized, you can try to draw it and label, but you should have that memorized. So 2 pi over 3 is right here in quad 2. Remember, that's a reference angle of pi over 3. And pi over 3 is always related to the ordered pairs 1/2 and square root of 3 over 2. And remember, that is a negative x in this quadrant. So the sine value, though, is the y value. So that's just going to be square root of 3 over 2. Cosine of 150. 150 is again in quad 2. That leaves you with 30 degrees as your reference angle. A 30-degree angle is, remember, the same thing as pi over 6. So that is the opposite of this ordering right here. So it's square root of 3 over 2 and 1/2. And that negative, again, is the x in this quadrant. So cosine is related to the x value. So in this case, it would be negative square root of 3 over 2. And then tangent of 5 pi over 6, that's also in quad 2 because 6 pi over 6 would be pi. And that is another, that's the pi over 6 for your reference angle. So that's going to be the same thing as 30 degrees. So 150 and 5 pi over 6 are the same measurement essentially. So this is that negative square root of 3 over 2 and 1/2 again. But you're doing tangent, so you're doing the y value over the x value, which you would take that and multiply by the reciprocal. Notice that the 2's cancel, so it's -1 over the square root of 3, which we would rationalize, and we get negative square root of 3 over 3. So that would be the answer for that tangent one for 5 pi over 6. Okay, when we go to the next slide, I'm doing some different ones that are reciprocals. So let's look at cotangent. The best way to do these is to actually just think of it as 1 over tan of negative 2 pi over 3. So that you're thinking of it as just a tangent, and then you'll just plug it into this formula when you get done. So negative 2 pi over 3, this is pi over 3, 2 pi over 3 is over here. So because we're going negative, we're going the opposite direction that we normally go. So this is negative 2 pi over 3. That means that this is a pi over 3, because remember that would add up to 3 pi over 3. So pi over 3, remember, is the same thing as the 60-degree angle. So that's when you have a 1/2 first and then a square root of 3 over 2. And that is negative on both because you're in quad 3. So remember the tangent here, this is a little tricky. I would go ahead and find the tangent right now. That is going to be, so the tangent of my reference angle is going to be the y value over the x value. And then I would reduce that. That's just going to be square root of 3 over 1, so just square root of 3. And then so we're going to write this as 1 over the square root of 3, and we again have to rationalize that. So square root of 3 over 3. Secant of negative 210 degrees, so that's going to be beyond 180, so we're going into quad 2 because we're going this direction. So that's going to be, what would that reference angle be? So that is the difference between 210 and 180 essentially is what we're looking at. Sorry, it's late for me. That would be a 30-degree, yes. So 30-degree angle. I should have been able to do that in my head. And then 30 degrees is again, remember in quad 1, that is related to a square root of 3 over 2 and then a 1/2. And in quad 2, that is a negative x and a positive y. Now secant, remember, is 1 over cosine. So the cosine value is the x value here. So that's 1 over negative square root of 3 over 2. If we times top and bottom both by 2, that makes it 2 over negative square root of 3. And when we rationalize that, that would be negative 2 square root of 3 over 3. So that would be B for that one. Okay, just a couple more things to talk about. This is finding acute angle solutions of equations with a calculator. So this is where we're going to finally show you how to use those inverse buttons on your calculator. When you have an equation like sine theta equals 0.5, theta is the angle and the answer is the ratio of the triangle that we're looking at. When you do the inverse button, you are going backwards. So you are saying sine inverse of the ratio equals the theta. And you can put that theta in either degrees or radians using your calculator button for degrees or radians, depending on which one they ask. So here's some things to note. Because sine, if you remember sine and cosine fluctuated between x and y values of -1 to 1. So notice, any ratio that you have for sine and cosine needs to be between -1 to 1. You cannot solve sine theta of 2 because that does not exist. If you try to do the inverse sine of that, it should say it's not in your domain. Cosine, same thing. Tangent, it can be any value, and the reason for that is, remember, tangent takes on any y value, because when you do an inverse, you're kind of plugging in y and finding x. So we're plugging in the ratio and finding the angle. So that's why this one can be any k value that we want. So any tangent equal to any value that is a real number, you can solve. But sine and cosine are bound between their lowest and max and their maximum height. So that's the only issue when you're trying to solve these. So notice that the calculator will use these specific intervals, and we'll talk about that more in class. So I just want to kind of show you what to do here. Now, the problem with these is that when you solve them, your calculator only gives you one answer. And in your 4 quadrants, tangent will be negative in not 1 quadrant, but in 2. So your calculator only gives you half of the correct answer. So we have to show you how to find the other half. And it's related to all science teachers are crazy. So the first thing we want to do is rewrite this as, let's do the solving of this. So we want to find theta by taking tan inverse of negative 1.5214. So you get your calculator, and we're in degrees here, and I know that because it says my answer should be between 0 to 360 degrees. And I'm also rounding to the nearest 0.1. So I'm going to type in 1.5214, make it negative, and then I'm going to use my shift button and do tan inverse. Now you may have to do the button tan inverse first, it just depends on your calculator. So this tells me theta is negative 56.7. Now that is not a correct measurement between 0 and 360, but I do like to draw where that would be. So negative 56.7 is right here. Okay, so let's first of all talk about why that's not in the correct version, because we want 0 to 360, and why it's not the only answer. Remember, in our saying, all science teachers are crazy. Tangent should be positive in quad 1 and quad 3. This is a negative value, so tangent should be negative in quad 2 and quad 4. Notice that we were only given the quad 4 answer, which means that the calculator, and the reason the calculator does that is because inverse functions have to be 1 to 1. So you can't get 2 separate answers from a calculator, it would be confused. So this is going to be our reference angle, since it's measured from the x-axis to the line, for this over here as well. Okay, so what we have to figure out is, how do these angles measure from 0? So for the first one up here, this is 180 degrees minus 56.7. This one is going to be 360 minus the 56.7. We're just trying to figure out that difference in the angle. So let's figure both of those out. So 180 minus 56.7 is 123.3. So one of my thetas is 123.3 degrees. The other one is 360 minus 56.7, which is 303.3. So there are my 2 angles that can meet the condition of a tangent being negative 1.5214. All right, for the last slide, I'm only going to do one of those as well, because we're going to spend the other 2 in class. And I'm going to do the cotangent one. Now in this scenario, we need to change our calculator to radians, since they're saying 0 to 2 pi, and we're rounding to 2 decimal places. So the first thing I'm going to do is rewrite this one, and I do something before. When I'm doing reciprocal functions, the first thing I do is I write it as tangent, which is its reciprocal. I do not write 1 over tan. I write this one as the flip. So you can flip one side, but not both. So I choose to flip the number side because that makes my life easier. So this would be theta equals tan inverse of 1 over 2.6815. So let's type this in and make sure we're in radians first. So I need to change that on my calculator. That's usually a shift button or a mode button. So this is parentheses 1 divided by 2.6815, close parentheses, and I'm doing inverse tan again. Now notice this is giving this to me in radians, so it's 0.37. So 0.37. So that is going to be in quad 1, because remember in radians 1.57 was the marker for the pi over 2. So 0.37 is like right here. Okay. All science teachers are crazy. This is tangent again. The places that tangent have a positive ratio, notice this is positive, is in quad 1 and 3. So that means there's also another, and this is the reference angle because it is measuring from the x-axis to that angle, is also 0.37. We'll do one in class together where that's not definitely the reference angle right away, and show you how to do that. That happens with cosine usually. So this is going to be my first angle, since it actually is in quad 1. So my first angle is 0.37. My second angle, remember, is pi plus that. So pi plus 0.37, and we can actually turn this into decimals. So pi plus 0.37 is 3.51. And those are my two angles for when tangent, or cotangent I should say, equals 2.6815. All right, that's the end of this video. Like I said, we're going to do all of the remaining ones together in class, but half of them are done, so that gets us a little bit further along where we need to be. I'll see you guys in class.